Hello, everyone. Welcome. Thank you all for taking the time out to join this video. My name is Matt DeMonbrun. I am a research director with a center called the Michigan Center for Adult College Success in the West Michigan area. You're probably watching this because you're in John McNaughton's class. John and I were colleagues and cohort mates at the University of Michigan ages ago, it feels like now. And he's asked me to give a little bit of a brief rejoinder on regression techniques. So we're going to talk a little bit about regression. I think it's a 15-minute video, so we'll go through it pretty quick, and then we'll talk through some of the basics for utilizing regression in Stata. So welcome to the session. Whether you're a student, researcher, data analyst, anybody really in the sort of world of any data analytics or using data to provide some context for perhaps a question that you have. Regression is probably one of the most powerful and widely used statistical techniques out there. Today, I'm going to walk you through how to run regressions data. So step by step, but first let's talk a little bit about what regression is and why it's useful. So what exactly is regression? In the most simple terms, regression is just a statistical method we use that helps us understand the relationship between two or more variables. So let's say that, for instance, you're a researcher and you're curious about what factors influence car prices. Things perhaps like the weight of the car or its miles per gallon, the type of engine, how many cylinders it has, et cetera, et cetera. All of those things could impact ultimately car prices. All of the new add-ons, different things that you can get in cars today. Regression allows us to quantify that relationship, right? So, for example, does a heavier car usually cost more, right? If we have more metal or more materials, does that mean that it's going to cost more? If two cars are similar, perhaps they have the same weight and otherwise are completely identical, but one is more fuel efficient, does that potentially raise or lower its price? So the dependent variable in this case, the thing that you're trying to predict or explain, would go on the left side of the equation. And I'll show you in a moment in Stata kind of what I mean by the left side of the equation. And the independent variables or the predictors would go on the right. So for example, I'm going to share my Stata screen. If we have Stata open here, perhaps we're looking at the relationship between weight, a car's weight, and its price. We would have a regression equation that would look kind of like price is equal to our beta naught, or our beta 0 plus our beta 1 times our weight. Now, if you have taken a pre-calculus class, or sorry, a pre-algebra class, which probably was ages ago, you will recall the simple slopes formula, which was y equals mx plus b. We do that in statistics. We just call it something slightly different. We actually call it generally y equals beta naught, which in this case is our b that we would use in the mx plus b equation, and then plus beta 1, which is usually our m or our slope in this case, times the variable, in this case x, right? So we've denoted here that our x, our independent variable in this case, is weight, and our dependent variable is price. So price goes on the left-hand side of our equation. We have our y-intercept, or our constant, which is our beta naught. We'll talk a little bit more about what this means and how to interpret it. And then we have our beta 1, but our beta 1, our slope, gets multiplied times our independent variable, weight in this case, right? So our beta 1, our slope, will increase or decrease based on the specific relationship with weight. So why would we ultimately look or use regression as part of that? Well, first, there's really two main things. The first is that it helps us to understand relationships, right? If I'm trying to come forth with a hypothesis that I believe that we need to make lighter cars because we need, lower cost cars that are available to the public, and I believe that weight is related to it, I want to be able to establish whether or not there's a relationship between those two things first. In the education world, which much of you are in, you might look at see whether there's a strong connection between education or years of education and income, right? If we're always touting that higher education, for example, is beneficial to a public and often leads to higher paying jobs, we should probably establish a relationship between those two things using data. And we would do that via regression. Other things in the marketing fields, oftentimes individuals will look at whether or not specific types of advertising spending really boost sales. Are those actually translating to actual increases in sales? So the first thing is understanding relationships. The second thing is that regression helps us with prediction. And so once we understand the relationship and once we've built a model that helps us to predict that relationship, we can actually go and predict the outcomes, like perhaps forecasting sales based on a marketing budget, forecasting an average income based on years of education, forecasting a price based on weight, any one of these things. The sort of third thing that's tangentially related to this is that regression allows us to control for other variables. You've perhaps learned about t-tests and ANOVAs up to this point. You can kind of control for variables in ANOVA, but a majority of these methods don't really allow us to be able to look or to be able to account for other variables that perhaps are not of our main interest, but ultimately are things that we want to make sure that we're not biasing our results. So let's say, for example, you're looking at the effect of exercise on health, but you know that diet plays a role in exercise and health. A multiple regression in this case, we'll talk about the differences between them both, would allow you to count for both and then to isolate the effect of exercise while holding diet constant. So we're looking at people that have essentially the same diet, but what happens as we vary the level of exercise, and does that actually have an impact on some sort of health outcome that we're looking at? And finally, all of this, our ability to understand relationships, our ability to predict gives us statistical evidence, right? Um, Now, we don't just say that X affects Y. We measure how strong that effect is and whether or not it's statistically significant. So, what are the benefits are, and anything that you learn about statistical terminology is that this sort of terminology of statistically significant and its importance. Statistically significant allows us to be able to generalize onto a broader population, right? Our results are our results. This is what we see in our sample, perhaps. But if we have statistically significant results, we can actually take that information from that sample of individuals. And as long as we've met a number of other criteria, including random sampling and randomized control trials, whatever we've done to sort of set it up and make it a random selection of our population, we can actually generalize our findings onto that population. So it allows us to be able to be able to sort of connect that into real world application. Now, there are two main types of regression that you'll see. There are lots of other ones that are available beyond the scope of this 15-minute conversation, but the two major ones are linear regression, which is what we'll focus on here today, and linear regression we use when your outcome is continuous. Prices, test scores, income, anything that has a range of items. Now, oftentimes, and especially in the world of education, we don't often have those nice continuous outcomes. Maybe we have a test score sometimes, but other times we might have was this individual accepted into the university or not? Did they fail a course or not? Right. And in that case, we only have a binary outcome, a yes or no. Did they fail? Yes. Or did they not? No. And so ultimately, when our binary outcome or when our outcome is binary, we would need to utilize a different statistical approach, which is called a logistic regression. And you may see a little bit on logistic regressions if you read anything in the literature. It's a pretty common form of regression. Now, there are tons of other more advanced methods, multi-level modeling, time series regression. When you really get into regression, you can get into structural equation modeling. There are lots of different sort of avenues and directions, but linear regression is kind of the foundational point that we often use to learn about this in order to sort of move forward with it as well.